welcome back to the channel. So when dealing with logical operators, you run into something called short circuiting. I talked about this in my previous video. If you haven't watched that video called logical operators, I'll leave a link in the video and in the description below so you can go check it out. But what short circuiting means is that the expression will be evaluated only until the truth or falsehood of the entire expression can be determined. So as you can see here, we have the and, or logical operators. So when using the and operator, if the left side is false, as you can see it's written here, then it isn't necessary to know what the right hand side is because the result must be false. And the same goes with the or operator. If the left side is true, it isn't necessary to know what the right hand side is. The result has to be true. So nothing is evaluated after. Now, here I have an example that demonstrates short circuiting. Here I have a method, a static Boolean test method. It's static, so I can access it in the static void main method. And all this test method does is that it takes an integer value and it prints out that value and it prints out the result of whether that value is less than 1, so true or false, and it also returns whether the value is less than 1. So here in the main method, I created this expression which calls the test method 3 times with different values. First 0, then 1, then 2. And I get the result in this b variable, and I just print out the expression is b, but true or false. So you might think that all 3 tests would be executed, but the output will show differently. Here I'll execute it. So as you can see, only the first 2 test methods of the expression were executed. This test 0 and test 1. So as you can see, first the value is 0, and then the result is true because 0 is less than 1. And then we have true. So we have to go further and check whether the next is true or false. So it goes test 1. Now the value is 1. Now is 1 less than 1 false? So we have false. So now we have true and false. So it doesn't even go and check the third test for the third test because there's no point. What's the point when it knows the answer already? So we get the expression is false. Now, the reason for short circuiting, in fact, is that you can get a potential performance increase if all the parts of the logical expression don't need to be evaluated. So you have also the non-short circuiting operators. Here, I'll write them in the comments. They're just the single form of the previous ones. So this is and or. Now, the difference is when we use these singular options, both sides will be evaluated. So here, I'll change these to the single versions. This is non-short circuiting. So if I run this program, see, even the third test, the 2, test 2 with the value of 2 will be evaluated. So as you can see, it could be expensive. The call could be expensive. So another reason to use the short circuiting versions of the operators is besides the performance increase, sometimes the right side might depend on the left side. Here, I'll show you an example. We'll make an integer I which is equal to 0. And I'll check whether I is not equal to 0. Put the logical operator and do, for example, 1 divided by I greater than 2. The thing is, we can't divide anything by 0, right? So I is 0, this will be false, and it won't be evaluated. The right side won't be evaluated. So if I run the program, everything's good. However, if I put the singular version right here of the AND operator and run the program, we'll get an error because the right hand side is also being evaluated, but we know we can't divide anything by 0. See, we even get the right error here. Here, I'll just show you a second example. If we use, for example, a string s, we make it null. And then we check whether s is not null. And we use the logical operator. And then check the length. If it's greater than 2, for example. So this will be good because s is null, so we get false. And now if I change this to the singular version, we'll get a mistake because we can't call the method on a null object. So however, there are sometimes you'll have maybe cases where you want both sides to be evaluated no matter what. Let's say you want to make a side effect in your program, but it all depends on what type of program you're making. So I hope you understood everything, and I'll see you in the next video. Bye guys!